Hello, ladies and gentlemen. This is Miss Skokin, and we're going to get started with our Chapter 3, Section 2 notes. But before we do that, I want you to take a look at this. We're connecting geometry to algebra. We're going to be using our knowledge of Algebra 1 to help us solve problems in geometry. And the instructions say, sometimes angle measures are given as algebraic expressions. When you know the relationship between two angles, you can write and solve a system of equations to find angle measures. So let's take a look at the very first diagram. We can see that we have two lines that intersect at a 90-degree angle. So what that means is each of these four angles measure 90 degrees. Now we notice that we've got two variables, an x and a y, in the two expressions that we have. We also know that those expressions need to be equal to 90 degrees. Both of them do. So because we have two what amount to equations, 6x minus 2y equals 90, and 3x plus 2y equals 90, we've got a system of equations in two variables that we can solve. Very conveniently, these are already set up for us to be able to use elimination. We see that we have negative 2y and positive 2y, so we can add these two equations together. We end up with 9x is equal to 180 degrees, and that means that x is equal to 20. And we have already found one of the values of the variables that we're looking for. Now we need to find y. In order to find y, we can substitute into either one of the equations. We can choose either the first one or the second one. I choose the second one, so I'm going to substitute in the x that we found. 3 times 20 plus 2y is equal to 90, and that means that 2y is equal to 90 minus 60, and y has to be equal to the difference, 30, divided by 2, the coefficient. So that means y is equal to 15. So our final answer, x equals 20, y equals 15. And now we're ready to look at example 2. So in example 2, we have a different setup. This time, notice what we've got. We have a linear pair, and, well, we have two linear pairs. We also have vertical angles. The vertical angles allow us to set up the first equation. 2x plus 4y is equal to 72. And the linear pair, if we set it up with these two angles, then the linear pair allows us to set up the second equation, which is 5x plus 2y plus 72 equals 180 degrees, because remember linear pairs are always supplementary. So let's see what we can do with this now. We're going to rewrite the first one, 2x plus 4y equals 72. And then the second one, we are going to combine like terms, which means take the 72 over to the other side, or another way of saying that is subtract 72 from both sides, and that's going to give us 5x plus 2y is equal to 180 minus 72, or 108. Now we're not exactly set up for elimination this way, but we see 2y and 4y. We know that one is a multiple of the other, and so we can multiply the top equation by negative 1/2, or you can think of it as dividing by negative 2. When we set it up this way, we end up having the opportunity to use elimination with elimination of the y variable first. We're going to end up with 4x, the y's cancel out, and 4x is equal to the difference, 108 plus negative 36, and that gives us 72. So x is equal to 72 divided by 4, which is 18. So we found x. Now we're going to plug x into one of the equations to find y. I'm going to plug into the first equation, 2x plus 4y is equal to 72. We plug in the value of 18, and we end up with 4y is equal to 72 minus 36, which means 4y is equal to 36, and y, therefore, is equal to 36 over 4, which is 9. We have found both values. X is equal to 18 and Y is equal to 9. Okay, now you have some problems to do to practice this on the next page. Once you're done with these 4 problems, turn the video back on and we'll get started on the 3.2 notes, angles formed by parallel lines and transversals, that is on the next page. Let's get started on our 3.2 notes. Angles formed by parallel lines and transversals. We already know what transversals are. It's a line that goes through 2 other lines. And now we're going to see what happens when transversals go through parallel lines. The objective says, prove and use theorems about the angles formed by parallel lines and a transversal. You can see that in our vocabulary we have a number of postulates and theorems that we're going to be talking about as we go through. What I'd like for you to do now is pause the video, do the warm-up questions, and then turn the video back on to check your answers. Okay, so you can see the angle relationships. The transversal is the one that goes from left to right. The other 2 are the lines that the transversal goes through. And if you have any questions about these, definitely bring these up in class. Let's take a look at some postulates that have been given to us now. Corresponding angles postulate says, if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. I want to remind you that these lines are parallel because they have those indicators. So lines P and Q are parallel in this picture. And what this says is if 2 parallel lines, which we have, are cut by this transversal line T, then the pairs of corresponding angles are going to measure the same. They're going to be congruent. So again, corresponding, we need to know those relationships. That would be angle 1 to angle 3. Angle 5 to angle 7, angle 6 to angle 8, and angle 2 to angle 4. Those are those corresponding pairs. Example 1 is going to help us practice this theorem, this postulate. And it says, we have a diagram to work with, of course. Find each angle measure using the corresponding angles postulate. The first one that we want to find is the measure of angle ECF. I'm going to highlight ECF. We know that we have 2 parallel lines indicated with those arrows and a transversal going through, and when we look at angle ECF, we see that it corresponds with the angle that is marked 70 degrees. So we know that ECF measures 70 degrees. Part B asks us to find the measure of angle DCE, which is the one that I'm marking in green. Now we have a few different ways to find that one, but I'm going to show you the way that is going to take a little bit longer the first time around, but it's going to allow you to see that there's more than one way. Now, to give you the shortcut, we would be able to say that since we already found the measure of angle ECF, and it measures 70 degrees, we know that the measure of angle DCE is going to be 180 minus 70 because angle DCE and angle ECF form a linear pair. But I'm not going to show it to you that way, and the reason is I want you to see with the corresponding angles postulate, we have a corresponding angle in angle ABC. And we know because of this postulate that if a transversal goes through 2 parallel lines, then those corresponding angles are congruent, and congruent angles means that we can set up an equation. Knowing that those 2 angles are congruent because they're corresponding, then we set up the congruency statement. From there we go to the equation statement. Measure of angle DCE is equal to the measure of angle ABC. We know that the measure of angle DCE is 5x and the measure of angle ABC is 4x plus 22. We can solve this very easily and very quickly with our great algebra skills. And once we have the value of x, we can plug into the equation that, or the expression I should say. So we're going to plug into the 5x, and we're going to find that the measure of angle DCE, which is the one that we wanted to find to begin with, is 110 degrees. On the next page, you've got some now you try questions. So I'd like for you to pause the video, work on those, and then turn the video back on when you're ready to check your answers. Remember to highlight and mark up your diagram as you go so that things the information that you need to solve these problems jumps out at you. Remember, work on these three, turn the video back on when you're ready to check your final answers. Hopefully you didn't have any difficulty with these, but if you did, pause the video, find your errors, and correct your work under the Now You Try questions. We're going to move on right now, and you can resume the video as soon as you correct any errors. If a transversal is perpendicular to two parallel lines, then all 8 angles are congruent. So what that would look like is if we have two parallel lines, and remember we're going to mark it with this, so parallel lines, and we have a transversal going through them perpendicularly, then what that means is all 8 of the angles formed, and that's 1, 2, 3, 4, 5, 6, 7, and 8. All of those are going to measure 90 degrees. We've got some theorems listed here, and I'm going to ask you to pause the video, read them, and look at the diagrams and what's called the conclusion in this particular case, but the angle relationships, and turn the video back on when you are ready to resume note-taking for example number 2. We already knew that when a transversal goes through parallel lines, the corresponding angles are going to be congruent to each other. But now, from the theorems on the previous page, we also know that alternate interior angles are going to be congruent to each other, alternate exterior angles are going to be congruent to each other, and same side interior angles are going to be supplementary, meaning they're going to add to 180 degrees. Don't forget that same side interior angles can also be consecutive interior angles. So let's take a look and see what we have on example number 2. So this says we want to find the angle measurement of angle EDG. We need to look at what other information we've got here based on the types of angle relationships that we were just talking about, and we notice that we have an alternate exterior angle situation right here. Of course, we need to make sure that we do have two parallel lines with a transversal going through them, and we do. So the way that we can write this up is the measure of angle EDG is equal to 75 degrees. Now, we can also solve for x while we're here. If we substitute in the expression that we have for the measure of angle EDG, x minus 30, we see that x is equal to 105. Question A was asking us to find the measure of angle EDG. Question B is asking us to find the measure of angle BDG. And BDG is located right here. Now we know that it measures x degrees. We've already solved for x, or we could have done it on this one, but we can say the measure of angle BDG is equal to x degrees, which is 105 degrees. So we have found the measure of angle BDG. Now, as a check, we can verify that those two are in fact supplementary. So if we were to add the measure of angle EDG and the measure of angle BDG, that would mean we're adding 75 plus 105, and that does in fact give us 180 degrees. So our check worked. With this diagram for question B, or for question A for that matter. The diagram also had another angle that we didn't really deal with, and that is angle ABD. And that one we could have used as a same side interior angle with angle X. We also could have used it as a corresponding angle for angle GDE. So we have a lot of options when presented with these parallel lines. We have down here now some now you try questions, which means it's your turn to practice this new skill based on these new relationships. I'm going to ask you to solve for the missing angles that you're requested to find under each one of those questions, and also write down which of the theorems you used to determine the missing angle measure. And then turn the video back on when you're ready to check your answers. Hopefully you found all of those straightforward and you used the correct theorem and the correct angle relationship. If not, pause the video, take a look, correct your errors, and turn the video back on when you're ready to talk about example number 3. Now, example number 3 is a music application, and we see that there are 3 parallel lines listed, lines L, M, and N. And we have 2 transversals going through them, lines P and Q. All right, now let's read the example. It says the treble strings of a grand piano are parallel. Viewed from above, the bass strings form transversals to the treble strings. Find X and Y in the diagram. So what we're going to need to do is determine what the values are of the missing variables X and Y. And based on what I'm seeing so far, we need to do a little work before we can determine what X and Y are. Let's start by pretending we can't see line Q for right now, and let's just zoom in to the diagram and see what's going on. We know that we have parallel lines and we have a transversal line P going through them. So what that means is corresponding angles are going to be congruent. So we have a corresponding angle here, and then we have another one here. We also know that alternate interior angles are congruent, and we're going to fill those in right now as well. After filling those in, we see that these also create vertical angles to each other, which we know vertical angles are congruent. And knowing what we now know, we know that we'll be able to set this expression 5x plus 4y equal to 55. Now let's take a look at the diagram again, but this time the 3 parallel lines and the transversal line Q going through them. We can see that we have the measure of 60 degrees, and we're going to fill in the corresponding angles that will also have the measure of 60 degrees. So we've got one there, we've got one here, and then we know that the vertical angles are going to be congruent, so we can fill those in as well. And now we can see that we're going to have the opportunity to set up another equation. This time 5x plus 5y is equal to 60. You may have guessed that between those 2 equations, we're going to be able to have a system of 2 equations and 2 unknowns, and that's going to allow us to solve for x and y. In order for us to use elimination, we know that we're going to need to multiply one of these by -1 so that we can add the 2 equations together, and in this case, get rid of the x's, eliminate the x's. So we're going to have -5x minus 4y equals -55. And the other equation is going to stay the same. When we add these 2 equations together, we're going to end up with y equals 5. And we have y. Now we can plug into either one of the 2 original equations to determine x. So 5x plus 5y, which is 5, is equal to 60 is the equation that I chose to use. This is going to mean 5x is equal to 60 minus 25. So we have 5x is equal to 35 and x is equal to 7. So our final answer for this question, x is equal to 7, y is equal to 5. And that is the last example in this section. bringing us to practice problems. So remember to bring any questions you have to class. Good luck with your practice problems.